Okay, so for this task, we're going to create a model of the oblique plane, line up against our principal planes of reference, and then we're going to put a cone in under the oblique plane to show how we use the cone method to find the true angle of inclination to any of the given planes. So we're going to start off, first of all, with a rectangle sketch, and we're going to go from the origin on the front plane, okay, and we're going to create a rectangle 300 by 150, as we always do for our front plane. We're going to go to the Surfaces tab, make that a planar surface, and that is now our vertical plane. We're going to do the same to create the horizontal plane. So on that top plane, I create a sketch of a rectangle going from that origin. So once the two of them are coming from the origin, it means we're going to be exactly in the same position then. So dimension that again, 300 by 150. And go to the Surfaces tab and make that a planar surface. So we have two planar surfaces now. I'm just going to put an appearance on both of them. Okay, so I have my horizontal plane and vertical plane. You can label them yourself in your own model, or you can label it on the drawing sheet afterwards. On the vertical plane now, I'm going to start a sketch from the XY line up at any angle and any length you want. So decide that yourself, and this is going to be one of the traces. So that's going to be our vertical trace for the horizontal or the oblique plane. So just draw a line from the XY line up and finish that sketch or close that sketch. Now start a sketch on the horizontal plane, and we're going to do the same thing but going down the way from the XY line. Any angle and any length. Before you close the sketch, rotate it so you can see it in 3D, and make sure then that the points on the XY line are coincident. So they should be resting on the same point there. And close that sketch as well. We're going to use them 3 points now to create a reference plane, and then we're going to make our oblique plane surface on that. So go to Features, Reference Geometry and Plane, and click the 3 points. Just before you tick that now, make sure that arrow is pointing up the way, so our normal should be up that way and not pointing down the way. On that plane 1 now, I want to start a sketch. 2 straight lines over the traces I've already drawn. And then between the 2 endpoints, I'm going to draw a spline. So just kind of a wavy edge to show the end of that plane. So that shows it goes on into the distance, but we're just showing a small portion of it. Surfaces tab again and make that a planar surface. And then we can hide plane 1. So I'm going to put a glass appearance now, so a clear appearance onto that oblique plane. So now I can just see my principal planes in behind that. Before we go any further, I'm going to color in the 2 traces as well. So just go back and change the sketch color and make them something that stands out a bit. So yellow. Okay, and on your models, you can label that VTH for your vertical trace and horizontal trace. Now we're going to insert a cone in under that oblique plane, and it's going to be a tangent to the plane. So that'll allow us to find the true inclination of the oblique plane to the horizontal plane then. So on that horizontal plane, we're going to start a sketch. We're going to go to a center point arc. So our center point is going to rest on the XY line. And then just draw a semicircle like that. So all the points rest on that XY line there. Draw a straight line then as well along the back. Now, you want to hold control, select the semicircle and select that horizontal trace and make them tangent. And that means now no matter where we move that trace, that semicircle will always be tangent to it. And we can close that sketch then as well. Now we want to sketch on the vertical plane. I want to use a center line, and then I want to go from that center point of the cone vertical up the way until it hits that vertical trace, and that'll give me a point then. I want to click the point function and add a point at the top of that as well. So that point is the apex of the cone we're going to draw now in a second. So close that sketch. Go to Features, Lofted Boss Base, and click the semicircle, and then click that top point. And now we have a cone in under the oblique plane. So I'm going to put an appearance onto that cone, whatever color you want. Okay, and that cone now, if we look in at an edge view of the plane, we can see the angle of the cone is the same as the inclination of that oblique plane to the horizontal plane. So we need to be able to show that in this model as well. So we're going to sketch on the oblique plane, and we're going to draw a line from the apex of the cone down to the base of the cone. So I'll just put it onto that horizontal trace first of all, and then I can hold Control, select the point, and select the circumference of the base, and make them coincident. And when the line turns black, that means it's fully defined. So we can close that sketch and put a color on it as well. And what that is showing us is the line of contact between the cone and the plane. Okay, and that is the normal that you create in the plan view as well when you're using this cone method. So that's the normal to that tangent, which is the horizontal trace. We're going to add one more thing to this. So we're going to create a new plane, a plane for us to be fit to look along. We're going to go to Features, Reference Geometry and Plane, select the horizontal trace, and then select the end point of that horizontal trace as well. We want to make sure the arrow is pointing out that way as well. So that's a plane now that'll let us look along that horizontal trace and see it as a point, and also see the oblique plane as an edge view. So I'm going to change the name of that plane over on the left hand side here. So right click, edit, and rename tree item, and I'm going to call that edge view of plane. And I'm actually going to hide that plane then as well. So that all that is going to be used for is to get a quick and easy view of an edge view of that plane. So now we can look at how the model could be used. So because we added in relations like the tangent relation, but we didn't put in fixed dimensions, we can actually move these traces to make a different size and different angled oblique plane. So if I grab that end point, I can drag it around, and you'll see the cone and the oblique plane updates with that then. I can do the same with the vertical trace. I can drag it way down, and you can see the cone updating as well. So you can mess around with that and see how the different angle of the trace changes the angle of the cone and so on. Alright, now if we want to see the edge view of the plane, what we do is click on that plane that we called edge view, right click on it and click normal to, and it'll quickly go and show us an edge view of the plane. So we can see the angle of the cone, and that angle of the cone is the angle of inclination between the horizontal plane and the oblique plane. So that angle on the cone stays the same the whole way around the cone. So then when we look in our elevation, the angle of the cone there gives us the true angle of inclination between the horizontal plane and the oblique plane, because that angle stays the same no matter how I revolve it around, and the cone itself is a tangent to the oblique plane. Okay, so when you've that done, present that on a drawing sheet as normal. Put your three drawn views in, your plan, elevation, end view. Make sure to label them and put in a pictorial view as well. So decide yourself whether you want that to be isometric, dimetric, trimetric, or just a random angle. You can label the model, or if you want, you can label it in the drawing sheet as well. So I'll leave that up to yourselves. But once you've that done, just make sure to put it on the sheet normally and export it as a PDF.